Hi class, this section is on equations, so let's get right to it. The first one, there are two squares, so that means we need to expand both of these out. So we'll start by doing that. X plus 5 plus 3 equals x minus 2, x minus 2. If you expand this, you're going to get x squared plus 10x plus 25 plus 3. This is going to be x squared minus 4x plus 4. Then you could just combine like terms. Notice at the left side, you're going to get x squared plus 10x plus 28. The right side stays the same. Then you can subtract the x squared from both sides, and you can add 4x to both sides. You can subtract 28 to both sides, and that leaves us with 14x equals negative 24. And then the final step is to divide by 14. And that's going to be x equals negative. We can simplify this fraction by 2. 12 over 7 will be our final answer. For the next problem, we have an equation that involves rational expressions. So in this situation, you need to factor all of the denominators first. So this is the difference of two squares. So this becomes x plus 2, x minus 2 after factoring. Then you want to multiply everything by the LCD. And the the LCD would be just, you need to make sure that you're including all of the denominator factors without duplicating them. So there's only 2, and there are x plus 2 and x minus 2. So that's what we're going to multiply every single term by. We're multiplying every single term by the LCD. And in the process, you're going to get cancellation. So we're going to be left with 4x minus 2 for the first term. Cancel the x minus 2's. We're left with x plus 2 for the second term. And then for the last one, both of these factors cancel out. And we're just left with 5x minus 6. Now it's just a matter of distributing and combining like terms and solving for x. So if you solve for x, you're going to, first combine like terms. You should get 5x minus 6 equals 5x minus 6. Oh, this is interesting. When you subtract 5x to both sides, you're going to get the variables to cancel out. And you can even add 6 to both sides, and you're going to get everything to cancel out. So you end up with 0 equals 0. That's one of those cases where when the variables cancel out completely, you're either going to be left with the true or false statement. In this case, we're left with the true statement because 0 equals 0. In the cases where you get a true statement, it means that you're going to get the solutions are all real numbers. So in other words, any number that you substitute into the equation will work, except whatever makes the denominator equal to 0. So you do have to be careful. So it is not all real numbers. It's going to be all real numbers except the terms or the numbers that make the denominator undefined or make the denominator equal to 0. So if you set this equal to 0 and solve for x, you're going to get negative 2. And over here, you're going to get positive 2. So that means there are two values where it cannot equal except 2 and negative 2. All right, so that's one way to write your answer is all real numbers except x equals negative 2 and positive 2. You can also look at the LCD and set those equal to 0. That will also tell you which values are excluded from the solution set. So as you can see, you still get the same result here, negative 2 and positive 2. So you can always look at your LCD to see which values would be excluded from the solution set. So you can write your answer like that, or you can also write your answer as all the values from negative infinity to negative 2 union negative 2 to 2 union 2 to positive infinity. This is a more mathematical way to write it. It's called interval notation, so I'll write that. Interval notation. All right, the next example. In order to solve an equation that involves a square, you need to undo the square by taking the square root of both sides. So the square and the square root cancel each other out, and you're left with x minus 3. However, whenever you take the square root of both sides of an equation, you always introduce plus minus. So plus minus the square root of 19, and then the final step is to add 3 to both sides. On WebAssign, you may have to separate your answers, 3 plus radical 19 and 3 minus radical 19. So just be careful. So you can write your answer like that, but WebAssign may have you separate the two solutions the way I just did. For this example, you want to try to factor, but you'll see that it's not going to be possible to come up with two numbers whose product is -2 and whose sum is -4. It just doesn't exist. So in those situations, you're going to have to apply the quadratic formula, which is -b plus minus square root b squared minus 4ac all over 2a. So your coefficients are 1, -4, and -2. So if you substitute those values into the quadratic formula, you should get -4 plus minus the square root of -4 squared minus 4 times 1 times -2 all over 2 times 1. And so that becomes +4 plus minus square root of 16 plus 8. Because of the double negative, when you multiply these three numbers, you have two negatives, which makes that a plus. All over 2. So this would be 4 plus or minus 24 over 2. And 24 can be simplified. The square root of 24 is the same thing as radical 4 times radical 6, which becomes 2 radical 6. So that becomes 2 radical 6 over 2. And here, because we have a common factor of 2 in the numerator, we can factor out the 2 and then cancel it out with the denominator. So if we factor out a 2, we're left with 2 plus or minus radical 6. And now we can cancel out the 2's. Careful not to cancel out the 2's like this. That would not be okay because of this 2. So you have to factor out the GCF first, and then you can simplify with the denominator. So that is our final answer, is 2 plus or minus radical 6. For the next equation, we have an absolute value. To solve for absolute value, first you need to isolate the absolute value first. So to do that, we should add 1 to both sides. And that gives us 6. Then we can divide by 2. And now we have the absolute value isolated on the left side. So once you've isolated the absolute value, then you can split up the equation into two separate equations. One equation would be 5x plus 2 equals +3. The second equation would be 5x plus 2 equals -3. And that's just by definition of absolute value. That's what you're supposed to do. So I'll solve for x for both of these equations, and that is it. So this is going to be x equals 1/5, and then this one's going to be x equals -1. So there are two solutions to this equation, which in most cases, when you have an absolute value equation, you should, for most of the time, end up with two solutions. The next example involves a radical. So similarly, we need to isolate the radical before we can get rid of it. So first step is to add x, because x is not underneath the radical. So let's start with that. So now we have the square root of 3 minus x is equal to x plus 3. Since now we've isolated the radical, now we can get rid of it by raising both sides to the second power, whatever the index on the radical is, that's what you have to raise both sides to. So square, square, that's going to cancel out the square root. So now we have 3 minus x equals x plus 3 times x plus 3. Expand that out by multiplying. You should get 3 minus x equals x squared plus 3x plus 3x plus 9. And now we can move everything to one side because we have a quadratic, which means you want to get everything to the side of the quadratic. So now we have our 0 equals x squared plus, if you combine all those like terms, that's 3, and 1 is 7x plus 6. And now we have a trinomial that can be factored. A times c is 6 and b is 7. Turns out to be 6 times 1 gives you 6, and 6 plus 1 gives you 7. So those two numbers will get placed into our parentheses. And now when we solve each of these factors individually, we get our two solutions, -6 and -1. However, for radical equations, you must always check your solutions, because it could be the case where one of the solutions doesn't check out, or maybe even both of them do not check out. So let's start by checking -6. I'll do it off on the side. So if you substitute -6 into x, you're going to get 3 minus -6 minus -6 equals 3. I'm going to put a question mark because we're not sure. So this becomes the square root of 9 plus 6. Does that equal 3? That's 3 plus 6 is 3. Clearly that is not true. So that's called an extraneous solution. Extraneous, which means it's not a solution. Now let's try -1. So for -1, I'll try that on this side. I'll create some more space. Check. X equals -1. Substitute it in for x. 3 minus -1 minus -1 equals 3 question mark. That becomes square root of 4 plus 1 equals 3. That's 2 plus 1 equals 3. This one does check out. So that is our final answer. Okay, now we have an equation that involves rational exponents. So in this kind of situation, you want to just treat this as a trinomial. I would do a u substitution. So let's let u equal this middle variable. So that's going to be x to the 1/3. And you'll see why in a second, why I'm doing that. And then if you square both sides, you're going to get u squared equals x to the 2/3. And now you see that this is exactly the same as that. And so now you can do a substitution, and you're going to have a quadratic. 3u squared plus 4u minus 4 equals 0. All right, and now we can do our diamond. So that's going to be a times c is -12, b is 4. The two numbers that would work out here would be, what is that going to be, 6 and 2? But you need a -2. Because the leading coefficient is not 1, that means we do have to put a u here and factor by grouping. So our four terms would be 3u squared plus 6u minus 2u minus 4 equals 0. And then we do our grouping method. So that's going to be 3u, u plus 2, -2, u plus 2, and then we have u plus 2, 3u minus 2 equals 0. And then if you solve these, you should get u equals -2 and u equals positive 2/3. So we solve for u. However, we need to solve for x because that's what the original variable is. So we're going to go back up to this original substitution equation that we came up with and plug in -2 in for u and then solve for x. So I'll do that in red. So we have negative 2 equals x to the 1/3. And the way you solve for x is you raise both sides to the third power to get rid of that 1/3 exponent. So that becomes x equals negative 8 is one solution. And then we do the same thing for the other problem, or the other solution over here. U is 2/3, so replace the u with the 2/3. So that's going to become 2/3 equals x to the 1/3. Raise both sides to the third power again. And we have x equals 2 to the third is 8, 3 to the third is 27. So those are the two solutions. All right, this last problem is a word problem. It says two children who are 224 meters apart start walking towards each other at the same instant at rates of 1.5 meters per second and 2 meters per second respectively. When will they meet? So let's draw a picture of the two children. So you got child 1 and you got child 2. Okay, this child is traveling at the rate of, I'll call it R1, 1.5 meters per second. This child is moving at I'll call that rate 2 at 2 meters per second. The total distance is 224 meters. So what we're going to do here is, because this child is faster, they're not going to meet in the middle. They're going to meet more to the left of the middle. So I'm going to just kind of mark it maybe approximately here somewhere, we'll say. So the whole distance is 224. So let's call this distance x. We don't know how far, we don't know what this distance is. We just know that it's going to be this distance plus this distance should add up to 224. So if the whole thing is 224 and this is x, then that means that this distance has to be 224 minus x. 224 minus x. Which should make sense, because let's just put a hypothetical number in for x. Let's say this was 100 meters. Then this would have to be 224 minus 100, which is 124. And if you add these two up, then that's 224. And you can do that for any number for x. So this is just an abstract way to represent the distances that each child is traveling respectively. Okay, and then we know that the time that it takes for this child to get here is the same time that it takes this child to get here, because they're starting at the same instant and they're meeting here. So this time is equal to that time. So we don't have to differentiate with time 1 and time 2. We can just call it t for both of them. So rate times time is equal to distance. So let's do child 1 first. Child 1. And then we'll do child 2. So child 1 is rate times time is equal to distance. All right, child 2 is rate times time is equal to distance. So here's the distance that child 2 travels. This is a rate, and this is the time. This is the distance that child 1 travels. This is a rate, and this is the time. Now we have two equations with two variables, which means we should be able to solve. And I would highly recommend the substitution method. So I'm going to substitute this into x, because that's what x is equal to. So if you do that, you're going to rewrite the second equation, which is 2t equals 224 minus, instead of x, we replace that with 1.5t. And now we have an equation in one variable, which we can solve by adding 1.5t to both sides. And we get 3.5t is equal to 224. Divide both sides by 3.5. We end up with t is equal to 224 divided by 3.5 is 64. And because the units are meters and seconds, and time is in seconds, that means 64 seconds. That's when they will meet, after 64 seconds. How far will each have walked? Well, we can figure that out by just plugging in the time here for child 1 and plugging in the time here for child 2. All right, so let's start with child 1. Rate times time is equal to the distance. So for child 1, the distance is going to be rate times time, which is 96 meters. And for child 2, you can do it the same way. You can multiply the rate, which is 2 times 64, and you should get 64 times 2 is 128 meters. And you can verify that those two distances add up to 224 meters.